Good morning, class. So today, guys, we will be going over all the formulas that we have learned, and we're gonna put them into a practice today. So here's your do now question. What you're gonna do is you're going to be on Pear Deck, and you're tell me which takes more time to complete, displacement or distance traveled. So if you're not already in this Pear Deck, I do have codes for every individual class. To go at their own pace. So just follow along with the YouTube video and we'll get through this Pear Deck, all right? So we can see that distance traveled, let's say that Mr. Lloyd's driving to school. So I'm driving all the way to school, and then, oh, I forgot my lunch. Well, time to turn around and pick up my lunch and then go all the way back to school, all right? So distance traveled refers to the length of a path, and then the displacement is the change in position from point A to point B. So we can easily see that displacement will always normally give you a shorter time period than your distance traveled. All right. So you're going to put your answer into the Pear Deck question area. All right. I'm going to move on to your agenda. Oops. Well, the agenda is right here. Here it is. So the agenda is that we just finished the do now. You should be putting in your answers for the do now. Secondly is formula practice. So we're going to be practicing the formulas together. First, I'm going to show you the formulas, and then I'm going to let you guys go on your own on the individual Pear Deck group questions, and then you have your exit ticket at the end, which is always fun. Okay, so let's get into it today. So question number 1 is talking about the same thing that I was talking about. So how do we describe position? My school is about 1.5 kilometers from where I live. One morning I had biked 0.5 kilometers before I realized I forgot my lunch. So I rode home and grabbed my lunch and rushed back to school. That's essentially the same thing about the do now question, but it's asking a full question. What's my displacement and what's the distance traveled, okay? So what I always do, I always try to make a practice of whenever I am doing physics problems, even when I was in physics class when I was younger, I would always draw them out. And so drawing them out always helps you get a visual to understand what's happening. So I'm just going to start off with this little dot. So this is my first position. Then I went forward. Let me make this a better dot. So I went forward, and we're going to say that time was point 0.5 kilometers. Oh, wait. Yeah, I had already biked 0.5 kilometers before I realized I forgot my lunch. So he biked that 0.5 kilometers. Then he realized he left his lunch. So he went back, all the way back to his house. So there. So he went 0.5 and he came back 0.5. So after he grabbed his lunch, he rushed all the way to school. So I'm just going to draw that drawing all the way to school, okay? So the school is about 0.5 kilometers, and his original starting point to where he forgot his lunch was about 0.5 kilometers, all right? So this is where the school is. This is where the house is, just so I can get a good visual, all right? So 0.5 kilometers, km. My handwriting is going to suck on this one. But so he went forward 0.5 kilometers, then he came back 0.5 kilometers. And what is this large distance right here? This large distance is 1.5. Why is it 1.5, Mr. Lloyd? I'm glad you asked that. It's because the school from his house, so this location is still his house, from his house to his school is 1.5 kilometers, okay? So he traveled that 1.5 kilometers there, and we also know that he returned on this trip. So the first question is asking about displacement. Remember, guys, displacement is only from point A, well, let's change colors. Point A, which was his house. Point A. This is an A. And then point B, which is the school, correct? So if I'm going to calculate for displacement, I'm only going to tell from point A to point B. We don't need all the extra stuff of him coming back and then turning around and then coming all the way back to school. All we need to know is the distance from point A to point B. And we know that he says in the beginning, my school is 1.5 kilometers from where I live. So that's telling you that this is the answer. So since we know that from point A, from his house to his school, that is 1.5 kilometers. So that is the answer for this section right here. Displacement is 1.5 km. And what's the total distance that he traveled? Now, to find the total distance, we need to know this distance right here. So we do know that this is 0.5. So the first time when he first came to school and forgot his lunch, he stopped here. Okay, so that was 0.5 kilometers. Then he came back. So if he came back that equal distance, that would be 0.5 as well. So 0.5 of 0.5, 0.5. These two added up is going to equal to 1 kilometer. So then, once he got his lunch, he turned around and went all the way to school. So you're going to add this number to these 0.5s as well. And your answer is going to be about 2.5 kilometers. All right. Now let's check if we were right. So what's my displacement? That is your change in x, okay? So we do know that the formula is delta x. Remember, x stands for position. You will have to know all these variables or these different small little words. So your final position minus your initial position is going to give you the answer for change in x, and that's what we did. So 1.5 minus 0. So he started out with 0. That's where he started out. But this whole entire distance is 1.5. So when he traveled all the way over here, we just subtract his final distance from his house, which is 1.5 kilometers, minus his initial distance from his house, which was 0, because he's already at his house at 0. All right, so 1.5 kilometers minus 0, that's going to give you 1.5. So we got the displacement. We did that correctly together. Good. What's my distance traveled? All you're going to do is add up all the distances. So he went to school, then he forgot his lunch, so he turned around. On the trip back, he went 0.5 kilometers again. Then you're going to add 1.5, and we got 2.5, just like I did up here. So you see that there's multiple ways to answer a physics problem. You see there's a way to draw it out and kind of conceptually understand it. And then there's the way to draw out the actual formulas. This is the way that we're mainly going to be using in class, is trying to know your formulas, okay? Because your formulas are very important. So everybody, in this description right here, you're going to use that formula for change in time. I'm going to write it out right here just so you guys can have it. And if you guys don't know, you can make a triangle with just pressing Alt and J. So the change in time is going to be equal to your final time minus your initial time. Remember that. All right. So I'm just going to put that formula right here so I can remember it. All right. And so school ends at about 4:30, and I got home today at 4:49 p.m. So we have these two times to subtract from each other. So how long did it take me to get home in minutes? All right. So what we're going to do is take our final time and subtract that from our initial time. So that final time that we have, 4:30, we're going to subtract that from 4:49 is actually the final time, because that's what time you got home, and school ends at 4:30. So we're going to subtract that from 4:30. Cash 4:30. There we go. So subtract that, and what are we going to get for our answer? So this will be equal to delta t. How long did it take for me to get home in minutes? Okay, let's see what the answer is. It is about 19 minutes. So if you got 19 minutes, you guys are correct. Okay? Hey everybody, so one note that we have not written down yet, and that's mainly because I normally tell this to you guys on the whiteboard. This is a variable. Oops. This is a variable. So this is a vocabulary word, but this isn't a heavy vocabulary word because as we get into the year, we normally know this off the bat, okay? So, variable, this is any, I'm getting recorded, and I don't know my definition for variable. Hold on. Okay, take this. Any word that is represented for a formula. Okay, so for instance, we have this one right here. T. This is the variable for time. So T is your variable for time. And we also remember that on the last question, X is your variable for position. We should remember that one. So T is your variable for time, and this is your formula to find out your change in time. So your change in a certain time period. And we did write this note down already on Monday, so we should have this already in. Okay, so what is the correct variable for change? Okay, if you don't remember this answer is technically right here because that triangle right here just means change, all right? So that's one answer for you. All right, guys, so after we have this one, we should be able to do the rest on our own. So you guys are gonna do the rest that are describing time. So this pair is check 5, and oops, not the answer. And then this pair is check 6, okay? We're not gonna go all the way down to this part with velocity. We'll just return on Friday to go over the section for velocity, and that will be a fun time. So for your exit ticket, guys, you can go and log into Edpuzzle. I'll do that right now. So you're gonna log into Edpuzzle like this, and then you're gonna go and complete this assignment here. Some of you guys have already completed it because I've signed it already, but this one is due on the 25th, and you're gonna complete this one. Just go ahead and finish this one over changes in position. All right, that is your last thing for today. If you have forgotten how to get into Edpuzzle, all you got to do is go into the hub. So go into It's Learning, the hub, and make sure you go into your class, which is my class. So let's say if you are in first period, you would go into, come on, computer. You're in first period, you would go find that first period folder, and then you would later go into the resources folder to find week number 1. Not tutorials, week number 1. So this is where you will, oh no, it's not week number 1, it is actually 914. Week 914 is where you'll find the Edpuzzle class codes to get logged into my Edpuzzle, okay? All right, you guys have a great day. Don't do any bad stuff.